All right, here's a tricky one. Find the equation of the tangent line. But oh no, it's a parametric equation. There's no need to panic here. We can handle this. We're going to use some simple rules of division to get the correct derivative, because that's what we need to find a tangent line, and then we're going to be off and running. So what rule are we looking for? Well, if we want to find the equation of the tangent line, remember we're looking for something that resembles dy dx. Okay, because that's where we get the rate of change for the slope. Okay, well, how does that work with a parametric equation? Well, I've got x's and t's and y's and t's. Here's the thing. Remember, on the top is change in y, on the bottom is change in x. So if I can find the derivative of y with respect to t, that would be dy dt. And if I could find the derivative of x with respect to t, dx dt, then what I'm going to end up with is dy dt over dx dt. Now, here's what's cool about this. We're going to treat dy dt and dx dt like fractions. And if you treat them like fractions, if you divide a fraction by a fraction, you have to multiply the numerator by the reciprocal of the denominator. What does that look like for us? It looks like the numerator, dy dt, times the reciprocal of the denominator, dt dx. Uh-oh, something cool is getting ready to happen. My teacher senses are going nuts. The dt's cancel out. My dt's are Dunskies. And what I'm left with is dy dx. Now, how cool is that? All right. So that's why parametric equations aren't so bad when you're dealing with them and taking a derivative. So let's just find out then what x prime would be. X prime then is going to be 12t. I'm going to move this t out of the way real quick. All right, y prime is going to be 5t to the fourth. Okay, so there's my two derivatives. What do I have to do? I've got to stack them up, y over x. So dy dx is equal to 5t to the fourth, my y part, over my x part, 12t. Now, use some mathematical common sense here. If I have a t on the top and a t on the bottom, you can divide one of those bad boys out. So this is ultimately going to give me 5t cubed over 12. That's the equation to find the slope of the tangent line. Now, how do you find the slope of the tangent line? Well, we need a specific point. Hey, they gave us one. They said when t is 1, find the slope of the tangent line. So to finish off this guy right here, I'm going to say 5 times 1 cubed over 12, which is 5 over 12. And then I just need to know the specific point that I'm at. Well, they gave us an equation to find the x point and an equation to find the y point. So what we're going to do is we're just going to use what they told us that y equals and x equals, and we're going to find these things out. So how does that work? Well, it works like this. I've got x equals 6 times 1 squared minus 3. That's going to give me my x coordinate. And on the bottom, I've got y equals 1 to the fifth. That's going to give me my y coordinate. And if I'm going to write the equation of a line, I need three things. I need an x coordinate, I need a y coordinate, woof, that's ugly, and I need a slope. If I've got these three things, I can write the equation of a line. Well, my x coordinate is going to be 6 minus 3, or 3. My y coordinate is going to be 1 to the fifth, or 1. And my slope is 5/12. So what does the equation of this line look like? It looks like y minus 1 equals 5/12 times x minus 3. Okay, if you don't want to write it like that, then just move the 1 over and be done with it. Y equals 5/12 x minus 3 plus 1. Boom. Game over. End of story. And you've got the equation of your tangent line.